Hey y'all, welcome back. Homework 5.2 here, where we're solving quadratic equations using the graph, and really this is just an excuse to get you to practice graphing these parabolas a little bit more. So we can find the solutions or the zeros where we find the x-intercepts of the graph. So where we look for the zeros are going to be, like right here, and I might as well just identify all four of these while I'm looking at them. Number 3, we see the two zeros here and here. And number 4, we don't see any zeros, so we'll come back to that one. So number 1, it's asking for the zeros, and we can do that just by looking at the graph and identifying the x-intercepts. This one's going to be at x equals, looks like 2 and negative 3. Number 2, there's only one x-intercept here. This is going to be when the discriminant is 0. So yeah, 0 is going to be at x equals 3. Number 3, we've got two zeros, one at negative, what is that, 1, 2, 3, 4, negative 4, and then another one at 1. Number 4 doesn't have any x-intercepts, so that means that there are going to be no zeros here, at least no real zeros. So that leads us to kind of where we're going with all this, and that is we want to solve this equation by graphing it out. Okay, so for number 5, we're trying to solve this by graphing. And this is just the parent function being moved down 4 units. You can find the vertex by doing negative b over 2a, but there's no b here. So the vertex is just going to be at 0, negative 4, which is right here. The negative 4 comes from actually plugging in the 0. Now to find the solutions here, what I want to do is set this x squared minus 4 equal to 0 and actually solve this. This is something that can be solved by square roots, so I'm going to do it that way. X squared equals 4, so x is going to equal either plus or minus 2. Okay, those are the solutions, and they are related to the graph in that that is where the x-intercepts are. So we've got an x-intercept at positive 2 and negative 2, and I'll plot both of those here. And then the graph is just going to look something like this, a little U. You don't have to be perfect, just kind of getting the general shape down. For number 6, start with the vertex here. I'm going to put this in standard form by adding x squared to both sides. So I'll have 0 equals x squared minus 9. Now I can solve it just like number 5. Just like number 5, the x coordinate of my vertex is going to be 0, since there's no b value here. So 0 squared minus 9 is going to be negative 9, and that puts our vertex at 0, negative 9. We can solve this using square roots, and that's going to give us the x-intercepts. First, I'll add 9 to both sides, and that'll give me x squared equals 9, so x equals plus or minus 3. Go ahead and plot our x-intercepts at positive and negative 3. Going to be roughly right here and here. And we can draw our parabola. Let's see, I'm going to do the best I can here with the mouse. Should just come down, hit that vertex, come back up through the x-axis. Here we go. Number 7. We've got 2x squared equals 2. I can simplify this a little bit by dividing both sides by 2, and that gives me x squared equals 1. And if I subtract 1 on both sides, I'll have an equation very similar to the ones that I have over to the left here. X squared minus 1 equals 0. Alright, so this is going to be set up very similar to the last two. The vertex, once again, has an x-coordinate of 0, because the b is 0. And then if I plug that in, 0 squared minus 1 is going to be negative 1. Once I have that plotted, let's go ahead and find our x-intercepts. If you're following the steps that we did on the previous couple of problems, this should be no problem. X squared minus 1 equals 0. If I add 1 to both sides, I'm going to get x squared equals 1. and then taking the square root of both sides gives me plus or minus 1. Need a point right here at -1. So this is going to be kind of crammed in there. But really all we care about as far as solving these equations is where are those x-intercepts. And we can see they're at positive and -1. Number 8, we've got a lot going on here. I think we ought to merge these two. I think we want this equal to 0 so we can actually do all the solving and graphing and whatnot. So let's subtract 2x and 4 from both sides, and we'll get -2x squared minus 2x and then plus 4 equals 0. We can simplify this a little bit. I might as well just stick this down here. Well, maybe I wish I had a little bit more room here. Let's just make this a little smaller, I guess. Hopefully you guys can see that okay. I'll bump it up. I'll bump it up one. Gosh, that still looks kind of small. Well, that looks okay. Anyway, next thing we want to do is divide everything by -2. Kind of simplify this equation up a little bit. And that'll give me x squared plus x minus 2 equals 0. All right, now this one is not set up as simply as the last one. So let's go ahead and solve this. First, let's find the vertex. And remember that the vertex has an x-coordinate at -b over 2a. So that would be -1 over 2 times 1. So the vertex, make a little note here, again, is -b over 2a. So that'd be -1 over 2 times 1. So it's going to be -1/2. And then if we substitute that into our equation, looks like we're going to get another decimal point here. Let's see, -1/2 squared is going to be 1/4. And I think I'm just going to go to the calculator on this one. So yeah, we've got 1/4 minus 1/2 minus 2. Is -2.25 or -9/4. So we could plot that. It's kind of a weird spot, but it's about -1/2, comma, -2.25. So it's going to be roughly here. Okay, so now let's find the solutions. This is factorable, so we'll go ahead and factor it. X squared plus x minus 2 equals 0. We can rewrite that as x minus 1 times x plus 2. So our two x-intercepts are going to be at 1 and -2. So our parabola is going to look like this. You know, something roughly like that. All right, there's number 8. Kind of wish I gave you a little bit more space to do all this scratch work, but I think we'll be okay. Number 9. First thing I'm going to do is kind of rewrite this in standard form. I'm going to subtract the x over as my first step. But then I'm going to multiply everything by 4 just so that I can get rid of those fractions. Really don't like having the fractions there. So that gives me x squared minus 4x equals 0. My vertex is going to be at negative b over 2a. So that'd be negative 1, so that's positive 1 over 2 times, or no, I'm sorry, negative 4 would be positive 4 over 2 times 1, which is 2. So 4 divided by 2 is just 2. And if I plug that in, I get 4 minus 8 is negative 4. So my vertex is at 2, negative 4. And now let's finish this graph off and get the x-intercepts kind of at the same time here. We've got x squared minus 4x equals 0. I'm going to get those. To factor this out, we need to factor out the GCF, with it, which is just x. So x times x minus 4. And then so x is going to either equal 0 or 4. So we're going to have a point here, here. Draw a little parabola. I've seen worse. Okay, so there we go. And here are our solutions down here. So I really just want you to get a feel for the fact that the solutions to these equations are simply where we're going to find the x-intercepts. Okay, the graph is related to the equation. Number 10. Let's get this in standard form here. It's going to take a couple steps, but we'll get there. First, I will square the x minus 2, and that'll give me x squared minus 4x plus 4. Drag all this back. There we go. And then I'll distribute the 3. Get 3x squared minus 12x plus 12 minus 4 equals negative 5. And then we'll just start bringing everything over to the left and simplifying from there. So there's nothing to combine here except for the constants. So let's just keep everything else the way it was. 3x squared minus 12x. And here we've got 12 minus 4, which is going to be 8. And then I need to add 5 to both sides to make this equal 0. So I've got 8 plus 5 is 13. And so, well, I either have to solve this by factoring, which may be a little tricky, or just go ahead and use the quadratic formula. So yeah, even if this can be factored, which I suspect it can't, I'm thinking this 3 and 13, that's 39. You know, coming up with two factors that add up to negative 12, I think I'm going to have a hard time there. So let's just start by, instead of worrying about the quadratic formula, we'll get to that in a second. Let's find the vertex first. So just like with the other ones, we'll start finding the vertex by doing negative b over 2a. So that'd be 12 over 2 times 3 is 6. So that'll be 2 comma something. And then to get the something, we'll plug that back into the equation. Let's see here. So that'd be 3 times 4 is 12. Minus 24 be negative 12. Plus 13 is 1. So our vertex is at 2 comma 1. Right here. And then our x-intercept, I wonder if there even are x-intercepts. You know, something's telling me that, well, now hold up here. We really don't even have to go further here. Let's go ahead and do it, but I can see that this is not going to have any real solutions because the leading term is positive, so I know this opens up, which means it's not going to cross the x-intercept, and that might be why I really couldn't think of any factors, is because there are none. So let's just go ahead and execute the quadratic formula here. X equals negative b plus or minus the square root. Get that plus or minus the square root of b squared. So that would be 12 squared is 144. B squared minus 4 times a times c all over 2a. So that'd be 2 times 3, which is 6. Now let's simplify this a bit. I'm going to put this in the calculator just so I make sure I don't make any mistakes here. 144 minus 4 times 3 times 13. And it gives me negative 12. So yeah, since this discriminant is negative, that means there are going to be no real solutions. And that means there's no x-intercepts. So don't worry too much about the graph on this one. We just know that it's going to go up and up. And we kind of knew that already because the a term was positive rather than negative. Moving on down to number 11, it says the graph models A, the area in square feet of a rectangular porch with a length that is 0.56 times W less than 28 feet given a width of W feet. Based on the graph, what is the width in feet of the porch with the greatest area? Okay, so this one, well, I don't know how else to put this. This should be a very easy problem to solve because there's nothing, you don't have to set up an equation or anything. It just says based on the graph, what is the width in feet of the porch with the greatest area? Okay, well the greatest area is right here, right? That is kind of big. We don't need it that big. Right here, right? We can see that greatest area is 350 feet squared. So it says what is the width in feet? So the width in feet is going to be 25. Okay, I can understand if maybe you got this wrong by picking J because you just weren't reading closely, but I really can't see any situation why you would pick 175 or 50, even if you're just kind of glancing at this problem. It's going to be tough to get this one wrong unless you're just not really trying and not really reading closely. So anyway, our answer here is H. There's not much more to say about this problem because we don't have to actually set up or solve anything. It's just a matter of reading the graph. Number 12, we're going to solve this, and it looks like we want to solve this by using the graph. So let's go ahead and simplify this. We got x squared minus 2x minus 5, and hey, there's actually a decent amount of space to work here, so that's nice. So here we've got x minus 1 squared, and I'll just try to break this down. X minus 1 times x minus 1. When we FOIL that together, we're going to get x squared minus 2x plus 1. And so now I'll distribute that 5 before I move everything over to the same side. Negative 5 times x squared is just negative 5x squared. Negative 5 times negative 2 is going to be positive 10, and then we got the x, and then we have a minus 5 at the end. Now we are going to start moving things over to the left-hand side so we can get this thing equal to 0. So we've got x squared plus 5x squared, so that'd be 6x squared. And then we have negative 2x minus 10x would be negative 12x. Then finally we've got negative 5 plus 5. That's just going to be 0. So actually we get a nice equation out of all that. We really don't even need the graph to solve this one. We'll go back and graph it, but the way I would solve this algebraically is really just factoring out that 6x. Now that we have it factored, we can set each factor equal to 0. We're going to get our two solutions here. If 6x equals 0, then x will equal 0. And if x minus 2 equals 0, then x equals 2. So we have two solutions here, one at 0 and one at 2. Really just to get the graph going here, let's find our vertex. We could actually just use this equation for the vertex. You can go back and use the original one, but I just think it's a lot easier to just go ahead and do this. But our vertex will be at negative b over 2a, so that'd be negative 12, or positive 12 over 2 times a, which would be 6. So that, yeah, 12 over 12, that actually just equals 1. Yeah. So our h is going to be 1. And our k will be what we get when we plug 1 in. So let's just see if we can't do this mentally, although you're definitely welcome to use a calculator. 1 squared is 1, so we got 6 times 1. That's just 6 minus 12 is going to be negative 6. So we got 1 comma negative 6. We got our vertex is way down here. And so a parabola is going to look something like this. There you go. Numbers 13 through 15, we're asked to use the graph to solve the equation. So we have the related equation up here and the graph. And so really, since all three of these are equaling 0, just like at the very beginning, we're just trying to identify the x-intercepts. So we've got the x-intercepts here, got 1 on negative 4, and then for number 15, there's just nothing. So for this one, we got x equals either, let's move this out of the way, negative 1 or 3. For number 14, we just have negative 4. And then for 15, we get no real solution because there are no x-intercepts. So there are going to be some imaginary solutions there, but let's not worry about those today. No real solutions. And that wraps it up for tonight's homework. Thanks for watching, and y'all have a great day.